Okay, so in the last video I introduced finding or what perpendicular lines are, what parallel lines are. So in this video we're going to do two examples where I want to find them. I want to find lines that are perpendicular and I want to find lines that are parallel. And so these are examples of each of those cases and how we do that. So the first case is the perpendicular case. Find the slope-intercept form, so I'm going to make sure I put it in the y equals mx plus b form, of the line perpendicular to the equation y equals negative 2/3 x plus 2 that passes through the point negative 2, 1. Alright, you can graph the lines by hand or on the calculator, and I'm going to use the calculator because I think most of you will do it that way, but you could do it by hand too. And that's just a way to double check, right? Just to make sure, again, they look like they should be reasonable, that it looks like they are crossing and creating a right angle. So first of all, we start with the line we're perpendicular to, negative 2/3 x plus 2, and the part that we need from this line is the slope, right? The slope of my perpendicular line is negative 2/3. So the slope of the line I want has to be the reciprocal negative, the negative reciprocal, or opposite reciprocal of that. And so, first of all, I flip it to 3/2, and then I want the opposite of it. This was a negative, so I want this to be positive, so this is the slope I'm looking for. And then I know it goes to the point negative 2, 1. And so I'm going to use point slope equation and then simplify my point slope equation to put it into my slope-intercept form. Alright, so point slope equation, remember, is y minus y1 equals m times x minus x1. Plug in your point and your slope. So y minus the y value, which is 1. Slope was 3/2 minus the x value, which was negative, times the x minus the x value, which is negative 2. And then I'm going to simplify it. Y minus 1 equals 3/2 x plus 2, right? Negative, negative means a plus. Distribute your slope. So y minus 1 equals 3/2 x. If you take 3/2 and multiply it by 2, the 2's will reduce and leave me with 3. So it's going to be just plus 3. And then add 1 to the other side. So the equation of the line I'm looking at is 3/2 x plus 4. There is the line that is going to be perpendicular to this line. Alright, so there's my answer, and then I'm going to check my answer. Alright, I'm going to check it by graphing. Alright, so I'm going to go to my graphing calculator. I've got to clear out stuff I had in there from before. Alright, and plug in my two equations. Alright, so the original equation was the fraction negative 3/2 x plus 2, and then my second equation that I found was, sorry, not negative 3/2, negative 2/3. Negative 2/3. Negative 2/3. This one was positive 3/2 x plus 4. Check. Positive 3/2 x plus 4. Alright, before I graph. Standard window should work. It's the same window I had before. And again, because it's not square, it's a little hard, but that looks reasonable to, and it is the correct answer. And so when we graph it, we can say, yes, it looks reasonable. So again, I'm going to say it checks graphically. Right, so there's finding a perpendicular line. So the next one is finding a parallel line. Parallel lines are a little easier to tell when lines are parallel when I graph them. So I want to find the slope-intercept form again, the y equals mx plus b, of a line parallel to the y equals 4x minus 5, and it passes through the line 5/8. So y equals 4x minus 5 is the equation I'm looking for. The slope of that line is 4. The slope of my parallel line is 4, and so the slope of the line I want is also 4. I'm going through the point 5/8, and so I'm going to use point slope equation and then put it in y equals mx plus b. So again, use the same equation I did last time. Plug in my point, which the y value is 8, the slope is 4, the x value is 5, and then simplify, distribute your slope. So y minus 8 equals 4x minus 20. Add 8 to the other side, and so y equals 4x minus 12. so this one should be parallel to this. I'm going to check on the calculator now. Keep in mind the y-intercept is negative 12, and so I might want to make my window a little bigger than 10. Right? And so I'm going to go to my calculator, clear out what I have. So clear. Type in my two new equations. So the first equation was 4x minus 5. My second equation that I found was 4x minus 12. Again, because of the negative 12, I'm going to go to my window. I'm going to go a little bigger in the y direction because I know negative 12 goes beyond 10. Alright, so I'm going to do negative 15. The rest of them I'm going to leave. If I don't get a good looking picture, I may adjust it from there, but I believe that should be good enough. So I'm going to start there, hit graph, and see if I can see my, and there I can see my lines. And now this one, it should look graphically, checks that, yeah, it looks pretty reasonable, that those are never ever going to intersect, that they're moving at the same rate, and they're parallel. And so we check them graphically. Alright, and we're done. So that's an example of finding a parallel and a perpendicular line. Alright, so we'll stop there.